Alright, so this question is called merge two sorted lists. It says merge two sorted linked lists and return it as a new list. The new list should be made by splicing together the nodes of the first two lists. So for example, we have two sorted lists, one being 1, 2, 4, and the other one being 1, 3, 4, and the output should be 1, 1, 2, 3, 4, 4. Alright, so let's go over what LeetCode has provided us. It's just a function called merge two linked lists, and what are passed in are the parameters L1 and L2. L1 is a fully formed sorted list, and so is L2. The problem in JavaScript is that it doesn't have any native linked lists, so in order for us to complete this question, I've created a class called ListNode for us to use, and you'll see why in a minute. Alright, the way we're going to do this is we're going to take the two linked lists and we're actually going to link them together by changing the references of a node to point to the next smallest item. So it's going to look like this. Instead of 2 pointing to 4, the next smallest one's actually 3. So 2 is going to point to 3. Now we're going to get rid of that because the next smallest one from 3 isn't 8 anymore. It is 4. Okay, now 4 can't point to null because there are still nodes remaining, so we'll just take the 4 and point it to 8. So as you see, the new linked list is now 1, 2, 3, 4, 8, 9, 10, null. Alright, let's show you that in more detail. The first step is to actually create a brand new head, and you can give it any number as a value, but I usually just give it like a -1. So now what you do is you look at the next two items in the linked lists. So which one's smaller, 1 or 3? 1 is smaller, so we point our new head to 1. So right now, our linked list is -1, 1, 2, 4, and null. But we're not done yet. So now that we pointed it to 1, we shift the reference to 2. So which one is smaller, 2 or 3? It's 2, so we're fine there. So now we move it one more. Which one's smaller now, 4 or 3? It's 3. So what we do is we break this link, point it to 3. So now we shift the comparison reference to 8. Which one is smaller, 4 or 8? It's 4. So this will no longer point to 8. We'll now point it to 4. Okay, and then you move the comparison reference to null. All right, once you've hit null, you're actually going to stop. You're going to break out of the loop that you're in. So now what we do is our linked list is currently -1, 1, 2, 3, 4, and then null. We're going to take whichever linked list ends with null, and we're going to replace its reference to null with the linked list that we have not linked to yet. So we'll get rid of this reference to null, and we'll just link it here. So our linked list at the very end is sorted. It's -1, 1, 2, 3, 4, 8, 9, 10, and null. And in a linked list, if nothing is pointing to a node, the node doesn't actually exist. So that's gone. And now the final step is we don't want our linked list starting with -1. So instead of returning the head node, we'll return head.next. So this will be gone. And this is the final result for the linked list. All right, so before we start, remember that I've created a class down here called ListNode. And what ListNode is a node that we can use. Why do we need that? Because remember, the first thing we have to do is create a dummy node over here. So how do we put that in the code? Let dummy equal new list node. We have to pass in an initial value. We'll just make it -1. It could be anything really, but might as well do -1. And then what we have to do is we can create a new variable called head and just make that equal to dummy. And why we have to do that is that while we're coding, the reference to dummy is going to keep changing. So let's say dummy is going to be this, then it's going to be that, and then it's going to be this, then it's going to be that. The reason why we have to initialize another variable to the initial dummy is so that at the very end, we can just reference whatever that initial value was and return it. So at the beginning, we're saying let head equals dummy, so that's here. That will always be the head, even though we're going to keep changing the reference to dummy. Then at the very end, we're going to return head.next, which is this, because head is -1, which was never actually in the two original linked lists to begin with. We created it just to make it easier to solve this algorithm. All right, so let's get rid of those arrows. Okay. So what's next is we have to create a loop. So while L1 doesn't equal null and L2 doesn't equal null. All right, so what's going to be inside of it? If L1.val is less than or equal to L2.val. So right now, remember, L1 is going to be right here, and L2 is going to be right here. So if the value of L1 is less than or equal to the value of L2, which it is, what are we going to do? We're going to say dummy.next equals L1, which would look like this. -1 is now pointing to 1. What else are we going to have to do? We're going to have to change the reference of L1 to whichever the next node is. So L1 equals L1.next. And what that's going to look like is, instead of pointing here, we're going to be looking at this. All right, so that was the case if the value of L1 is less than or equal to the value of L2. But now we have to take care of the opposite case. So if L2.val is less than or equal to, sorry, we don't even need that, else, it already inherently means that L2.val is less than L1.val. So else dummy.next equals L2, and then we do L2 equals L2.next. All right, so there's one more thing we're going to have to do before we move on to the next loop. So far we've been comparing L1 and L2. What we have to do is, now that we're advancing along the linked lists, we also have to update the value of dummy. So remember, at first, dummy was -1. Then we linked that to 1. And how do we do that? By using its next property. So what we'll have to do to keep doing this over and over is we're going to have to change the reference of dummy to whatever its next node is. So that now, whenever we find the smallest next element, we can use the new dummy's next property to link to whichever one is smallest. All right, so how does that look in the code? We just make dummy equal to dummy.next. All right, so once we've finally broken out of this while loop, it means that our reference node in one of the linked lists is null. So remember, the next step for that would be to attach the remaining linked list to the end of that first linked list. So to illustrate it again over here, so we would go 2, 3, 4. So it would look like this. 3 points to 4. You'd move the reference to null. So now we'd have to attach this to the end of this linked list. The errors would actually be the opposite of that. So let's do that correctly. It would be like this. So how you do that is you say if L1 doesn't equal null. So if the first linked list is not the one that has the null reference, we would say dummy.next equals L1. Otherwise, like in our example, so right now we are at this step, dummy, which right now is the number 4, dummy.next equals L2. So else dummy.next equals L2. Okay, and all there's left to do is to return the sorted linked list. The only problem right now is that the head of the linked list is the number -1. Remember, -1 was never in either of the original linked lists. So we can't return -1, which is head. We have to return whatever the next property is from head. So head.next would be the number 1. So return head.next. All right, let's see how we did. Good, and let's submit it. All right, so we see this is better than about 66% of JavaScript submissions. So as usual, the code and the written explanation are linked down below. See you next time.